Take it from the top. We'll assume we have nothing there. So let me show you those words and form that picture as we go. So again, two hot air balloons. So I'm going to draw them on here as well. So we're going to basically have well, that's not very good. My artistic skills. And then, so balloon number 2, and then balloon number 1. Well, maybe a little further. Like that. And, well, now balloon 1 looks longer than balloon 2. Whatever. I can't make it look perfect. Let's just go on. So it says, again, one more time, the distance, right here, the distance from the bottom of the basket, this is for the first balloon, to the top of the balloon is 15. So from here to here is 15 again. This is 15. Maybe I should, it's just bugging me that it doesn't really look that way. Let me bring it down a little bit. Bring it down, so maybe like that. There we go, so there's number 1. Okay, so that's 15. Let's kind of adjust my picture as we go. So from the top to the bottom. See how I use double-sided arrows, right? I think I was saying that just as we were ending last time. Really encourage you to do that. Like I said, when I teach calculus, engineers do this kind of thing. Important skill. In other words, you want to do that instead of just writing 15. You know what I mean? I've tried to help many students over the years, and they'll just write like 15. And that's just not going to be as helpful to you, because when you get in the middle of the problem and everything's kind of confusing, you won't be clear like, what is that 15? Where is that 15? So over here, to double-sided arrow like this, 15. Okay, and then they're saying for the second balloon, this distance is 20. So for the second balloon, this distance is 20. So that would mean from here to here, the distance, top to bottom, is 20. And then it says the top of balloon 1's balloon is 6 feet above the bottom of balloon 2's basket. So from here to here is 6 feet. The top of balloon 1 to the bottom of balloon 2's basket is 6 feet, even though it doesn't really look like 6 feet on my diagram. Okay, it's 6 feet. From the ground up to balloon 1's basket is 50. So here, I'll put the ground down here. This is ground. And so from, what did it say? From the ground up to the bottom of balloon 1's basket is 50. So from there to there is 50. It doesn't look like 50 on my diagram. From the ground up to the bottom balloon 1's basket. How far is it from the ground to the top? To the top of balloon 2's balloon. So from the ground to the top of balloon 2's balloon. That's what they want. That's what they want from us. All right, is that good? See how I drew that all out and tried to keep a track on everything? So let me give you a second again. Rather than me just whipping these out, that's one important part. How far from there to there? Can we figure that out? Because we know so look, basically we're trying to go from the ground, down here, all the way to the tip top of balloon 2, right? That's the plan. So you can do that many different ways. I can start right here and say, okay, go up 50, now I'm at this height. And then go up 15, now I'm at this height. I'm just kind of going from bottom to top. But then I need to go the rest of the way, meaning I got to know that distance, huh? Do you see the issue I'm having? To get from bottom to top to find the total distance, you got to go 50, and then 15, and then I don't know to get to the top. Now the I don't know, that height right there, how can I find that height right there? At 20 minus 6. Does everybody see that? So the 20, this is going to be 20 minus 6. Or 14, isn't it? From this level on up is 14, because it's 20, take away 6. Right? So that's 14. So then what's the total height? It's going to be 50 plus 15 plus 14. Isn't it? So it's at 79. Is that making sense? Does everybody see what I did there? Questions I can answer on that. It's all about the diagram, isn't it? And reading those words and being able to draw a diagram from those words. Is that making good sense? Questions? There we go. Let's try that one. Twice Mark's age is the same as Dad's age minus Mark's age. Dad is 45. How old is Mark?
Dad's age minus 10.
So that makes sense. Twice Mark, so she's using M for Mark. Twice Mark, 2M, 2 times. Let me make that M a little better there. Twice Mark, Mark's age, is, now what is O's? Equals, that's my equals. Yeah, is the same as, or is the same as, that's a big fancy is, and Dad's age minus Mark's. What'd you do for Dad's age?
I plugged in the 45.
Yeah, because they said it's 45 over here, huh? 45, Dad's age minus Mark's. Is that good? Does that make sense? How we just directly take an equation from those words? Can you solve that thing for M? Let me give you a second. What do we do there to solve that for M? Remember when you have letters on both sides? Yeah, get rid of one of them, like add the M would be a really good idea. Yeah, there's different ways, but that's one probably the best way. Yeah, so add M to both sides, right? You don't want the letter on both sides, you want to get rid of one of them. So add the M to both sides, is that good? And what's the left side? 2M and M? 2M squared. No, I'm sort of half joking, but I want to make sure you know those algebra rules. It's not 2M squared. When do you make letters squared in algebra? When you times them, when you multiply them, exactly. We're adding, so when you add, you just add the numbers in the front, 2M, 1M, 3M, right? You all knew that, just want to make sure. Equals 45, last step. Divided by that 3. And M is 15. Mark must be 15 years old. Good? All is well? Questions on that one? So we're using a variable. Good thoughts, right? So I'm not going to do anything fancy here. I'm just going to track through what it's saying. He entered the large building on the bottom floor and went up 10 floors. What I've seen over the years with problems like this with diagrams and stuff is students will go, okay, bottom floor, up 10, down 6, up 20, and they'll just kind of go quick with things. I mean, do the problem like your grade hangs on it, which means, because it does on an exam question, which means be super careful. In other words, be really careful. Handle with care. So what do I mean? What am I talking about? What's wrong with that? Well, I would be careful about, I don't know. I would just go like this. Here's what I mean. I would just go, okay, bottom floor. And then I liked what I saw a lot of you guys doing, is I would just go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 floors up. Well, I shouldn't write 10 there, because that's actually the 11th floor, isn't it? See how it's easy to mess up? So anyway, so forget about what I just said there. Just mark them out. Just to exactly what we're right here right now, right? I just started on the bottom, and I literally just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Keep going. What then? Down 6. So I'm right here now. I'm right here. I'm gonna go down 6. Okay. 1, 2, 3, 4, 5, 6. Now I got to be right on the level there, because my grade depends on it, kind of thing. Well, not my grade, but this is what you would do if you really want to be careful. See how I'm just mapping it out? I'm not just add, subtracting, hoping the best. Be real careful. Next, up 20 floors. So now, from this level, go up 20. 1, 2, 3, 4, 5, 6. Back up 6, and then 14 more, huh? I'm going to go 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, I'm losing track now. So much for my carefulness. All right, so what was it again? It was up 20 from down here. So I'm going to count this again. This is up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's up 20 from here. And what does it say about that? And then down 5 to the middle floor. And then down 5 to the middle floor. So from here, down 5. 1, 2, 3, 4, 5. Right there is a very important place. That's the middle floor. Does that make sense? How I map that out? Now, how many are below that middle floor? Well, I don't know. Let me count them. 1, 2, 3, 4, 5, 6, 7. Be careful here. 8. And then this is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 below the middle floor. Did you track with that? So that means there's 19 down here, 19 up here, and 1 in the middle. There are 39 floors in that building. Is that good? Was that the answer in the back? Yeah. Did you see that? Now, could we have just done that without all that writing answer? Probably. Let me see. Let me just try it again. What is it? Up 10, down 6. Let me just write it up here. So it's up 10, down 6, up 20, down 5. Yeah, thanks. Up 20, down 5, and then you're on the middle. So what does that mean? If you go up 10 and down 6, you went up 4, huh? And if you go up 20, down 15, together you went up 15, right? Because I'm just subtracting the downs. That good? So up 10, down 6 is up 4. Up 20, down 5 is up 15. That means I went up 19 floors to the middle. So this is the middle. There's 19 floors down below. Yeah, does that make sense? So you could just do it without subtracting instead of drawing it all out. I just like to be super careful. When my grade's on the line, I don't trust in anything but precision. Draw it. Be real careful. Does that make sense? Is that one okay? Kind of a messy one. We good on that? All right. Let's try number 8. Irene has 440 and nickels. Now, let me write it out for you here. Number 8. So $4.40 in nickels and dimes, and 60 coins. 60 coins. How many of each? So they're saying, yep, how many of each? All right, let me give you a second there. Okay, looks like you guys are doing good things. Let me show a couple of techniques, and I never care how you do anything. Both are good. It's all good learning exercises. One of them, I was noticing Paige was doing the guess and test method. That's really valuable. So let's just, it might sound, I don't know if you've ever been told never guess in math. That's actually not true. Guessing is an excellent strategy as long as you test and you'll learn from it. Let me show you. I'm going to show 2 ways. I'm going to do it by guessing and testing, and then I'll go back and I'll do it with algebra, with letters. And I don't care what you do on the test. Anyway, it's totally fine. So here we go. I'm going to guess at how many nickels. You know what I always guess at first? Whenever I start a guess and test, I start with 10. Because it doesn't really matter. I'm not really trying to get it right the first guess. I'm just trying to get going on my thinking. So I just put down 10. 10 nickels. Who knows? And then dimes. Whoops, my pen's. Dimes. How many dimes? Yeah, because there's got to be 60 coins total. There would have to be 50 dimes in that case, wouldn't there? So I'm tracking through. And what would be the value of the nickels? If you have 10 nickels, it would be 10 times 0.05, meaning 50 cents. And what's the value of the dimes? It would be 50 dimes times 10 cents each, which would be 0.50 also. The value total would be 50 cents and 50 cents, $1. What's it supposed to be? $4.40.
The dimes would be $5.
Oh, right. Thank you. $5. I was testing you. Well done. Yes, thank you. $5. 50 dimes would be $5. So that would be, did I do the other part right? 10 nickels to 50 cents, yeah. So that would be $5.50. It's supposed to be $4.40. So that's not right. Of course, you never get the right first guess. So let's try again. Should I go higher or lower? I don't know. I'm going to go higher. I think I need to actually go lower, but I'm not sure. I'm just going to try going higher. We'll see as we go. So 20 nickels. If there are 20 nickels, so my first guess was 10, I'm going to, all the rest of the numbers come from the guess, don't they? So if there were 20 nickels, how many dimes would there need to be? 60 coins total. There'd have to be 40. And how much would the nickels be worth? 20 times 0.05, use your calculator, that's $1, right? $1? Let me know if I mess up again. Value of the dimes, if you have 40 dimes at 10 cents each, that would be $4. That would make the total value $5. The value went down. Oh yeah, that's good. That's the right direction. It's like playing warmer, colder. I'm getting warmer, aren't I? Right? I'm headed in the right direction. How do I know? Well, the real thing is supposed to be $4.40. I'm headed towards that. I went from $5.50 to $5. I'm headed towards $4.40. This is a very valuable skill for young folks to learn to guess and test this way, just to work out their logical thinking. You know, it isn't all algebra. We're trained so much with X's and Y's. Math is not all just X's and Y's. This is good, valuable math right here. So let's go up to 30. I remember I used to, my oldest child, I used to give him guess and test word problems to work on when I went to work every day. And I'd come home and I'd check out. It seems like torture, doesn't it? But he would work on them, and he's getting a math degree here at Fresno State this semester. I'm sure it's just because of that. I single-handedly made that. No, I'm just kidding. But I think that was helpful. It is good for the young mind to be thinking about word problems. All right. 30 nickels, there'd have to be 30 dimes, 60 coins altogether, right? So what would the nickels be worth? 30 times 0.05, what is that? $1.50? And the dimes would be worth 10 cents each, $3. Oh, that's it. Oh, no, that's close. So that this up and this up, that'd be $4.50. So I'm close. I need to go to 440, which is a little lower. So what does that mean I should do with the nickels? Should the nickels go higher? Like go like 30, 35 or 40? Or should I go lower like 25? What should I do next if I want this total to go down to 440? You see the pattern? As the nickel number's going higher, the money total's going lower. And I want it to go lower still. So I'm going to do what with the nickels?
Higher.
Higher still. See the pattern?
Smaller increments though.
What's that?
Smaller though.
Yeah, but just a little bit, like maybe 31, 32, I don't know. I'll guess at 31, you tell me I'm wrong already. This would be 29. I really don't know. I'm just guessing. Oh, I'm sure you're right. 31 times 0.05. What's that? 155. $1.55? Is that right? Yeah. And then this is 29 times 10 cents each. $2.90. Add that up. Is that $4.45? I'm guessing. So it looks like I need to go one more step. I should have listened to Janelle. She's right. One more step. And 32. This would be 28. 32 times 5 cents each is $1.60, and 28 times 10 cents each is $2.80, $1.60, $2.80, $4.40. There it is, 32 nickels, 28 dimes. Do you see how the guess and test table works? Does that make sense? Kids can do that without algebra, right? You can have them do this like in the 3rd or 4th grade. That's what I had my son do. He was young. They can read as soon as they can read. This develops logical ability. Reading, stepping through things, right? Math ability, logic. That's really what you're going for. And teaching young folks about math, you're teaching them to think logically and in patterns. That's really it. It's not about moving X's around. That's just one part of math. That's not all of math. Anyway, I can do it again. I know many people you guys have taken a lot of algebra, so you're probably most comfortable with algebra, and that's fine. I'll redo it with algebra as well real quick. So how would I do it? 440 in nickels and dimes. How would you do that in algebra? 440 in nickels and dimes? How much is every nickel worth? So what am I going to do? 0.05 times the nickels, 0.10 times the number of dimes is $4.40. This would be, I'm going to redo the problem now using algebra. Remember these? You may probably did some of these in your algebra days. Those were the best days of your life, right? Hey, Susie, is that what you were saying outside? Those were the best days of algebra days? Or marching band days? Or maybe I got those confused. 0.05 in plus 0.10d is 440. Right? Because every, however many nickels you have times 5 cents each, plus however many dimes you have times 10 cents each is the total money, right? But then there's one other fact I haven't used yet. What do I do with the 60 coins? Yeah. N plus D is number of nickels plus number of dimes is 60. Remember when you have 2 letters, you need 2 equations? I don't know if you remember that detail from algebra. So there we go. So now, how do I solve 2 equations, 2 letters? Do you remember? From algebra?
You need to multiply one of the equations by something that will make one of the variables equal to the other variable, and then combine the 2 the opposite of it. So it's like
right. So you're doing the elimination method, also called the addition method, where you make them opposite. Like you're talking about, Giselle. Multiply by the bottom equation by 0.05. Did I call that Janelle? I was it. Janelle. Multiply by 0.05, and then add those up and get those ends to cancel out. And that's great. If you remember that and you're good at that, that's actually my favorite method as well. I've found over the years most people are a little more comfortable with getting one of the letters alone and plugging into the other one. Both are great. So I'm going to do the second one just because I've seen people seem to be more comfortable. So if you just move the D over, well, how about subtract D? Subtract the D from both sides. Then I will have N equals 60 minus D. So I took the second equation, I got the N alone, and then I can take that and plug it in for N to the other equation. Does that make sense? Have you seen that kind of thing before? So here, I'll bring it down where it's a little easier to see. So just bring this equation down here. 0.05 N plus 0.10 D is 440, and then I'll just plug this right here in the place of N, because N is equal to 60 minus D. That means wherever you see N, you're allowed to replace it with 60 minus D, because it's the same as 60 minus D, isn't it? So you solve for, you take one equation, solve for one letter, plug into the other. So that's the other way. So 0.05, and then the N's going to go right there. 60 minus D, like that. And then the rest, plus 0.10D is 440. So this is a lot more algebra. You have to remember, and young people haven't had that. They start young now, but they don't start till 4th grade or 5th at the earliest, right? Anyway, in my day, you didn't start till high school, but now they start them young. I know, but anyway, so younger folks won't know how to do this. They would have to do this method, right? So multiply that through. Use your calculator. 0.05 times 6. Is it 12? I think it's 12 minus 0.05D plus 0.10D equals 440. 12 minus 0.05. Remember all these algebra rules I just distributed there? Is that okay? And then minus 0.05 plus 0.10. 10 minus 5 is 0.05. D is 440. How do you finish solving for D? What do I do next to get D alone? Subtract that 12. Am I doing something wrong? What is it? Oh, yeah. 30. Shouldn't it be? No, 30. It should be 3, huh? Yeah, I'm being crazy. You guys got to stop me when I'm doing stuff. Don't just keep watching. I don't know everything. I mess up. All right. Thank you. Yeah, no, because I thought, oh, that answer is going to come out negative. That's what alerted me. Something negative was coming out. And that can't be. Yeah, so that should be 3. Thank you. I just tried to multiply in my head and did a botched job of it. Subtract 3 from both sides. Gonzo. So then we come up here. I'm kind of running out of room. I'll bring it up here. So we got 0.05D equals 440 minus 3. 140. Last step. Divide by 0.05. I'm going to do this one right. I'm going to try. 20, and there's 8. So 28. Is that right? 28. So 28 times. How do you figure out how many nickels? Right here, it says, bring that over, nickels, or just keep it the same color there. Nickels is 60 minus D. Put in the D. Nickels is 60 minus 28. Nickels is, what is that, 32? Or just subtract from 60, huh? 60 coins total. That'd be probably a simpler way. Oh my goodness, look at my time. I got to get moving. So I solved that problem 2 ways, by guess and test table and by algebra. I don't care which way you do it. It should be easy. 3 to the 50th power. You got it? I'm joking. I mean, you can do it if you want to. You'll see, it won't tell you the ones digit. It'll tell you something like, I don't have my calculator with me, but it just goes way off the screen. Calculator cannot help us. We cannot see the last digit, which is the ones digit, right? The ones digit's all the way down at the end. And this number has like 23 digits to it or something. It's gigantic. So there's no way we're going to see the ones digit. So the calculator can't do it. We need logic. So how can we do this 3 to 3? We're running out of time. So here's what I suggest. You look for a pattern. So take your calculator. The calculator can help. Just take 3 to the 1, 3 to the 2, 3 to the 3. You'll get 3, 9, 27, 81, 3 to the, bless you. 3 to the 5 would be 243. 3 to the 6 is, I think, 729. Look at the ones digit with me for a minute. 3, 9, 7. I'm just circling the ones digits, right? What do you see? A repeating pattern. 3, 9, 7, 1. 3, 9, 7, 1. 3, 9, 7, 1. Forever. See how it's just going to repeat? 3, 9, 7, 1. Then it starts again. 3, 9, 7, 1. The ones digit cycles through a repeating pattern. 3971, 3971, 3971. Okay, so how do we get out to the 50th digit?
Long divide.
Yeah, it's just like that one we just had in the last test, which I'm going to finish grading this weekend. I hope you got that one. It's when you need to go way down the line, 50 spots, and what am I going to long divide by? By 4, because it's a cycle of 4. So everybody says, like if the marching band, I was using, the Janelle in the marching band. I didn't even know Janelle was in the marching band, and Jesus had been in the marching band. But yeah, as the marching band enters the stadium, if they bring in the first person that does a 3, then a 9. See if the marching band can agree to do this at the next football game. Are they playing today? San Diego, right? I heard that they're playing San Diego. Or tomorrow, Saturday? If the weather permits, I heard, right? Anyway, so if it's not too bad air quality out there. 3971, 3971, 3971, If they entered the stadium that way, what would the 50th person have? Well, it's how many groups of 4 go into 50. How many full groups of 4 would enter that stadium? If we long divide this, we'll get 12 full groups of 4. That's 48 people. And a remainder of 2, the last 2. So So we'd have 12 full groups, 3971, 3971, 3971, 3971, 12 of those full groups, and then the last remaining 2 people would enter the stadium. So we would go 2 down the line. 1, 2. It's going to be a 9, isn't it? That makes sense? So we're out of time. The 10th one, you can work on the answers are there.